Good morning, kids. Today's class we are going to discuss about some pathfinder Olympiad problems. Some very good. It will be useful for the advanced level preparation also. I have the cylindrical pipe. There's a pipe, a cylindrical pipe of radius r. So the diameter will be 2r. It's kept on the floor. This particular is floor. Will indicate all. This is the floor. This one is a pipe, open pipe it is, open at both ends. And we have next spheres. There's a one sphere, there's another sphere, which are kept here. The radius is giving something equal to more than 0.5 r. Spheres are there, cylindrical pipe kept on the horizontal floor. Then what will be the value of small m by capital M? So the arrangement, the minimum value of M, the arrangement topple. So we are discussing about some toppling idea, toppling of connected bodies. That's what this particular problem is based on. So we'll first start with the free body diagram. The forces acting will be the normal contact. The first we'll start with the weight. The weight of this will act here. The weight of this will act. The normal contact. By the upper sphere on the pipe. By the pipe on the upper sphere. Similarly, by the lower sphere on the pipe. Okay, then by the pipe on the lower sphere. Then there'll be a normal contact also between the this is M1G and right theta, the weight of the spheres. Small m is what M1 I'm choosing. Okay, this has, let it be M2. Then let this be the normal contact on the lower sphere, let it be N2. N1. Now what is this N2? This sphere, second sphere, we'll call this as second sphere. The second sphere will exert force on the pipe. This is N2. In turn, the pipe will exert force on the sphere. This N1. This N2. Similarly, first we'll analyze this one. So what is this N1? Force exerted by the first sphere on the pipe. Similarly, by the pipe on the sphere. By the sphere on the pipe. By the pipe on the sphere. Okay, so we'll call this as say 1. Let it be this as. Okay, then there'll be also normal contact acting between the spheres. Okay, it should be like this. Here, these two spheres are in contact. You can see it. This will be the common tangent. This will be common normal. Then the forces acting, the normal contact here will be N, will call it. And the normal contact on this second sphere, the lower sphere, let it be N. Let them make an angle theta. The theta will come. Okay, this assumption, let this length be x. and this length will be smaller. This length will be smaller. So what is the total? This length 2r should be equal to, from the data, 2r should be equal to r plus x plus r. Or 2r equal to 2r plus x. Keep this equation 1. And then, but what point it can topple? The normal contact will by the floor on the pipe will act at this particular point, all by the ground or the floor. And what about the second sphere? Here, second sphere, when pipe is about to, when this pipe is about to topple like this, the second sphere will not be in contact with the floor. This is the basic condition. When this pipe is about to topple, okay, what is the toppling point? Toppling point will choose P. And we have Q. The whole idea is like this. Huh? Are you getting now? There's a pipe. Huh? And these are the spheres. Then there's a floor. Oh, there's a 3D diagram I'm giving. You can keep this also. No. So we'll come back to this one. So first, the normal contact by the second sphere on the pipe N2, by the pipe on the second sphere, by the first sphere on the pipe N1, by the pipe on the first sphere with N1, weight M1G, M1G, the normal contact by the second sphere on the first sphere, by the first sphere on the second sphere, and it should act along the line joining the common normal. So these are the basic thing. Then here we'll write it here. Second sphere, sphere 2 will not in contact with flow when pipe is about to topple about. This is the basic idea. Rest on everything, free body diagram, solve it. We have to just write the equation for the torque about the point P. And this is the core idea of this particular problem. Rest on everything, okay, we can manageable. Now we'll write down we'll go for the equilibrium of each sphere. We'll write down the equations. So sphere 1, forces acting along x-axis. N cos theta should balance minus N1. Here. This will be component of this. Component of this will be N will come here. No? This N only, you produce it. So N, this N cos theta. Some correction. N cos theta, this one. This N cos theta will balance this N1. Huh? So this is one equation. Similarly, N sin theta. n sine theta will balance this weight. So writing this equation, so from these two equations, we can write cot theta equal to n1 by m1 equation. Then net torque about point P should be zero. What about sir, like this M2G are not showing the weight M2G of the pipe? Somewhere it should act here. Actually, it should act. It should act at the. It's a long pipe, no. The weight M2G should come to the center of mass. The space not available. I'm showing it here. Let's proceed that one. Net torque about point P. This is sphere one. Huh? For the sphere two, we'll write it equation. Sphere two, n cos theta, n2. This will be theta. This n cos theta should balance this n2. Now we'll write down the equation for the torque. Net torque about point P should be zero for the pipe. Then wall will set up torque due to the normal contact N1. N1 should be equal to this total distance needed. This is R. This is R. So this length will be equal to 2R sine theta. And this length is equal to R. So N1 into 2R sine theta plus R clockwise plus N2 into R plus the weight M2G into this will be anti-clockwise equal to zero. This is the very important part of the problem solving. About point P, the torque due to the normal contact N1, this should be equal to 2R sine theta. This length will be 2R sine theta plus R, and it will be clockwise. Then torque due to this N2 on the pipe. On the pipe, this N2 is acting. This will set up torque no, about point P, and this will be the perpendicular distance, and it will be anti-clockwise. And torque due to the weight of the pipe, M2G will act here, and there's a perpendicular distance, and it will be anti-clockwise. Okay, fine. Now we'll substitute all the related values. So N1 equal to M1G cot theta R2 sine theta plus 1. What about N2? N2 is equal to N cos theta. Cos 2 plus this will be as usual equal to 0. So now substitute the value of this N also. N cos theta, we have to N cos theta, we can write it as N1. We have substituted N2 as N cos theta. Then N cos theta, I can write it as N1. G will get eliminated. So this will be M1R cot theta equal to M1R cot theta plus M2. Nothing one M1R cot theta, M1R cot theta will get eliminated. I'll explain further. M1R cot theta to M1R cot theta sin theta, M1R cot theta equal to M1R cot theta plus M2. These two will get eliminated. So 2 M1R cot theta sin theta equal to M2. So M1 by M2 is being asked. So this will become further 2R cos theta. For cot theta will be cos theta by sin theta. What is cos theta from the diagram? From this triangle, from this triangle, what is cos theta? Cos theta will be this x by 2r, x by 2r. And what is x? X will be from here, 2r minus. So this should be your answer. Some good problem, like toppling due to connecting bodies we have discussed. Okay, the primary thinking part, the thinking part of the problems I'm highlighting. Writing this torque equation. Okay, the most essential. These are the important ideas, sir. Then we are discussing about the equilibrium. We are discussing about the equilibrium of the first sphere. Here you can see that along x-axis, n cos theta will balance n1, n sin theta will balance n1g. Then solving these two will get one equation. For the second sphere, n cos theta will balance n2. Okay, this for second sphere. Then for the pipe, the forces acting n1, n2, and its weight, and the normal contact. Why the torque due to normal contact is 0 about point P? Because it will intersect axis of rotation. The torque will be only due to N1, N2, and M2G. And it's going to topple about point P. The particular pipe is having tendency to topple about point P. This is the thing. So writing this torque equation, then substituting all the conditions. This is from the geometry, looking at this one, because this radius is R, X, R. Okay, kids, huh? We'll take the next problem. Hello, kids. Now we'll discuss one more the Olympiad problem from Pathfinder. So we have a problem like this. A cup having shape of frustum cone is placed on horizontal tabletop, horizontal floor. tabletop. Mass of the cup is M2. Okay, here the mass of the cup. Okay, somewhere we'll show it acting here like this. Then, and diameter of its bottom is D equal to 10 centimeter. We'll add on that one. The B equal to AB. This particular thing, sorry, PQ. Then the rod, uniform rod of mass 20 gram is placed in the cup as shown, and it is inclined at 60 degrees. So this particular thing is a rod. This is the rod. It is inclined, and this angle 60 degrees it is making with the bottom of the cup. Then the weight of will act here. The weight of the rod will act here. Let it be mg. Okay, then he's asking about the will not turn over. Turn over means should not topple. This word turnover, what is the meaning of that? Not turnover means no toppling. There should not be any toppling. So for that, what is the conditions? So we'll get into the free body diagram. There's a cup. Agreed, everyone? That inside that we are placing this rod. The length of the rod is L and the weight M1G is acting. Here the weight M2G will act. Then about what point it can topple this particular cup? Because of this rod will exert force on it. The rod will exert force on it and it will topple about point P. The maximum length is asked. The maximum length is being asked. Then there will be a normal contact between the cup and the rod. Okay, call that as say like a N naught. Similarly, on the cup, N naught. Then the normal reaction will pass through the point P by the ground, by the floor, water will happen. Now the cup is having tendency to rotate about point P, to topple about point P. Then when the length of the rod is maximum, then the normal contact will pass through the point P. If the rod were not there, then the normal contact will pass through this point P. As the length of the rod increases, then the normal contact will shift. When it is about cup is about to topple, it will topple about point P. This is one basic idea of assuming why about P it will topple. Okay, now we'll take this rod and the cup as system and we'll discuss the net torque about point P. And write it in when as the length of the rod increases, normal reaction NP shifts towards left. And when the system is about to topple, normal reaction passes through. So therefore, net torque about P should be 0. We'll write down the equations. Net torque due to ohm. Okay, this length is what we need. This length. This length will be how much? L by 2. And this length is L by 2. We'll call this as point DN. The length BD equal to AD should be equal to L by 2. So O will write it. AO plus BO should be equal to L by 2. Then from the triangle, this is AO L by 2 theta. So this length should be equal to how much? L by 2 cos theta. You extend like this. So let this be say some ND will E will write it. And the distance PQ equal to this is D. Okay, now we'll write down the torque about point P. Net torque about point P should be called torque due to the weight of the rod. M1G into X anti-clockwise. How it is about point P, the torque due to the weight M1G, you can see this is R bar, this is M1G. So it will be anti-clockwise. And this M1G into perpendicular distance. Then the normal reaction NP will pass through the point P only. So torque due to this will be 0. Torque due to the normal reaction by the cup on the rod, by the rod on the cup. Both will be equal and opposite about point P, these two. So that will get nullified. Okay, I need not to show it. The net torque due to these two normal reactions about point P will be equal and opposite. Now all will be left over now the torque due to only the M2G. And how much M2G should be equal to? Plus M2G D by 2. This will be clockwise. Next again comes why there is no normal contact here. Here also there will be normal contact by the cup on the rod, Na. On the cup, Na. We'll show those things also. Again, torque due to them about point P. Due to these two will be equal and opposite. So we'll write here note. Torque, net torque will be 0 about point P. Okay, what is X? X we can calculate now. This L by 2 cos theta will be equal to X plus D. So what is X equal to? L by 2 cos theta minus D. Minus M2G D by 2. I think we know all the values. Huh? L is what? The unknown thing. So this will be M1, G will get cancelled out. M1 L cos theta minus D equal to M2 D by 2M. Substituting all the values, will get the required length. This will be our answer. Now do calculation. This will be your answer. So these are some observation a student has to make. The free body diagram. See, once you have, if you draw the free body diagram, then you can analyze. Without free body diagram, without like you're not showing all these forces and you are learning. And somehow, okay, this equation I'm thinking, there's something wrong. You must justify, okay, this rod is in contact with the cup here. The normal contact is acting. So then why that torque is not coming? Similarly, the rod is in contact with the cup here. Then there's also normal contact at D. Then why there's no torque about point P? Then why the normal reaction will shift? Because it is about to topple about point P. No? So it will, the normal reaction will shift. This is one basic idea of the toppling. No? The normal reaction will shift. Entire toppling, this normal reaction. There's almost in many problems we used it. Okay, these are some simple, even can be asked in advance. It's a pathfinder problem, can be asked in advance. Very important for us. Okay, kids, we'll see the next problem. Good morning, kids. We'll have one more a small pathfinder problem based on the toppling idea. Here, a cardboard strip. There's a cardboard strip bent in the shape of letter C. So here it is. It is bent in the form of letter C. It's put on a rough inclined plane. This is that rough inclined plane. As shown in figure, at what angle of inclination alpha to the horizontal? Will it topple? It is going to topple here. I think the particular diagram is there. So let's assume that mass of the sheet be 3m. This is that sheet. Agree this. It is bent. It is bent. So then this is the rough inclined plane. Fine. Now, what about the forces that are going to act? We should get familiarized with the forces. The weight of this will act. Mg cos alpha. The weight of the other one also will act. We'll do one thing. Sheet 1, 2, 3. This is what, when you bend it, third one you are seeing here, one is here, and the two is somewhere here. Then its weight will act. Mg sin alpha. That of the two also will act. That of the one also will act. And all that Mg sin alpha, Mg cos alpha will not at same point. I'm trying to, you should try to imagine. They just take sheet and bend it, like a letter C. Then for each sheet, the weight center of mass will be at its center. Then Mg cos alpha, here Mg cos alpha. Mg cos alpha of this, the sheet 2, this will be Mg sin alpha, Mg cos alpha. This will be sheet 2. Sheet 1, I'll draw it. I'll draw it. This will be the sheet 2. And this is our inclined plane. Huh? For the sheet one, I'm showing it here. For the sheet one also, mg sin alpha will act here. The sheet one will be here. Sheet three, this is. Sheet one will be here. For sheet one also, mg sin alpha. The sheet one, I'll show it separately. Again, this will be the inclined plane. Okay, agreed. This is what happened, you know. So now, about what point it will topple. It will topple about point P, or at the midpoint of that, the plane diagram, only this visible. No? At the midpoint, here. About this point, it will topple. I think it's not visible for me. At the midpoint of the sheet 2, or about this edge. Huh? So here actually sheet 1, 2. So this is the point P, you can show it here. This is A, B, C. So how the things are there? A, B, C, and this is C, this is D. Oh, everyone know, now you must able to understand that, because more than this, I can't uh, explain, because there's only the, if it were in classroom, I would have taken the sheet. Here, I don't think so, like possible. So therefore, maximum, I'll putting the information for you. I'll share it. The green color, and are you noticing the difference? This particular thing is a green color. This was that sheet. Second sheet is like this. About point P is what we should discuss the torque. Net torque about point P. And let me show clearly. Net torque about point P. At the midpoint of the BC, about point P should be 0. Then all will set up torque. Torque due to mg sin alpha will set up about point P. And what is this length? This length should be equal to a by 2. Should be this length should be equal to a by 2. So mg sin alpha into a by 2. I think all due to all three sheets, there'll be torque due to mg sin alpha. No? Here. Due to mg sin alpha, there'll be torque about point P. And due to mg sin alpha of the sheet 1, mg sin alpha of sheet 2, mg sin alpha of sheet 3, all will set up torque about point P. And how much equal to mg sin alpha a by 2. And since 3 mg sin alpha are there, 3 mg sin alpha a by 2, and this will be clockwise. Then torque due to mg cos alpha. Torque due to mg cos alpha of the sheet 3 will set up a torque about point P. And how much this distance should be equal to a by 2. This distance should be equal to a by 2. This distance. Then similarly, torque due to the mg cos alpha of sheet 1. This distance also will be a by 2. Not about C it will set up, about P only. The perpendicular distance will become A by 2. Therefore, 2 times of mg cos alpha A by 2. This will be anti-clockwise. Okay, sir, why not 3 here? The torque due to mg cos alpha of the sheet 2 will pass through that point P. Here. Will pass through about point P. Here mg cos alpha of the sheet 2 will act like this. And it will pass through the edge, this edge BC. And it will exactly intersect at the point P. So this particular thing will not set up a torque. So we'll write it here. No torque due to this. No torque due to this component. Okay, then simplify. I think this will be minus tan alpha equal to 2 by 3. This will be your answer. I think the diagram, physical diagram, if you understand, that's all everything manageable. So we'll take the next problem. I have the solid hemisphere. I think that solid hemisphere of radius r is placed on the inclined plane of inclination theta. What is the maximum value of theta for which hemisphere will not topple? We are discussing about the toppling of hemisphere on the inclined plane. This is the hemisphere, what we have. Where the center of mass of the hemisphere will be? Solid hemisphere. I think that this is very important. That particular thing is needed. So the center of mass of solid hemisphere is at a distance of 3r by 8. Let's come for this one. This will be 3r by 8. What are the forces acting will be mg sine theta, mg cos theta, then the friction. In what direction, about what point it can topple. Now, because of the, let's talk about this one, about center of mass. The torque due to mg sine theta and mg cos theta will be 0 about center of mass. Torque due to friction. Torque due to friction will be anti-clockwise. So this particular hemisphere is having a tendency to rotate anti-clockwise. Then who will balance that? If you say normal reaction will pass through center of mass, net torque will become non-zero. So therefore, the normal reaction will start shifting. Then at one particular point, the normal reaction, when about to topple, will pass through the point. This idea is very important. How to check the normal reaction means, I'll put it once again. The torque due to mg sine theta, mg cos theta about center of mass will be 0. Torque due to the friction will be anti-clockwise. Then it is not sliding nor toppling, let's assume. Then we will balance the torque due to friction, the normal reaction. If you assume normal reaction like this, the net torque is non-zero and it must topple, but it's not toppling. So therefore, the normal reaction, in fact, will shift. It will act like this. It will act here. Finally, at one point, when it's about to topple, normal reaction will pass through point A. When about to topple. It's asking maximum value of theta. So the normal reaction will pass through point P when theta is maximum. I think this idea. Will bring the normal reaction. The normal reaction will pass through the this will be mg sin theta. We'll take the net torque about point A. Net torque about point A should be 0. Then torque due to normal reaction Na and the friction. It will intersect axis of rotation. What all torque will be there only due to mg cos theta and mg sin theta. And what is this distance will be? This distance should be equal to, this should be equal to R, no? So here net torque about point A should be 0. So mg 3R by 8. Okay, now this will be mg will get cancelled out. Tan theta equal to 8 by 3. So the maximum value of theta will be tan inverse of 8 by 3. Simple problem. So just only you should have the ability to analyze the problem properly. Okay, kids. Huh? So almost I think all the different ideas of the toppling I explained. Learn them. Why only like this? The forces are acting. Analyze the equation. How that equations are written. Why only we should take that about point A only, because it's having tendency to topple about point A. That's why the net torque about point A should be 0. Okay, we'll meet again with few more better problems in from other topics in coming classes. Okay, thank you, kids. Thank you, all of you. Bye. See you.